This message brought to you by Sambo and Honky, and now by Cracker and Boy.
So today we're looking at these axles that I'm installing on this trailer, and I was looking at this and thinking, there's not a whole lot of clearance here between this axle and the trailer frame. I think, in a passenger vehicle that I'm used to, I expect a whole lot of travel, but maybe on a trailer it's not all that important. So anyway, I thought I'd take a closer look at all this to understand better what's going on. So this is set up per the instructions with about 2 inches of clearance between the frame and the axle. And we've got this rotating thingy that connects the two axles so that if one drops into a hole, the other one takes up a little bit more weight. So the two axles are actually talking to each other a little bit. But if one drops into a hole and the other one takes up the slack, then this thing here will drop, which means that the axle will drop and take up more of that 2 inches of clearance. So you'll notice that I welded this thingy in here, and you're saying, didn't they send you the hangers like this, the right height, so that you don't have to do that, or are you raising this up out of spec? And the answer is no, I am not. These hangers were designed for a 2 3/8 axle, and this is a 3-inch axle, so the whole thing just ends up wrong. So they should have sent different hangers with this axle, but they didn't. I think they provide the same hangers for all of the axles between 2 and 7,000 pounds, and they should have different hangers for the different axles. Of course, they know this, but they just don't bother to mess with it because, we are consumers and we consume. So here's the instruction sheet, and it says, all dimensions shown should be considered as zero load on suspension without weight of trailer or cargo. And it says allow 1.5 inch deflection at rated capacity. Okay, so that means this will get closer to that by 1.5 inches at rated capacity. And it says for best suspension performance, allow 2 to 2.5 inch clearance above top of axle at bottom of frame. So let's just work with the 2 rather than the 2.5 to make this simple. So if you set it up for 2 inches, then when you have 1.5 inches of deflection when fully loaded, then you have a 1/2 inch available spring compression, and that's all. So if you're driving down a gravel road, you're going to be taking up that 1/2 inch pretty frequently. And if this guy gets to rocking, then that's going to be taking up that 1/2 inch also. So the implication is that when you're driving down a rough road and your trailer is pretty heavily loaded and you hear a lot of noise back there, that's because the axle is smashing into the frame. It's not just because these little shackle things are making a lot of noise. It's because things are smashing together. Okay, so why do they say only this 2 inches of clearance? Well, let's take a look at the spring and how it's designed. So here's a leaf spring with a nice curve to it, and if I take this straight edge and align it with the top edge of the top leaf and come over here and notice that there's about 2.5 inches of clearance between here and there. And so this means that when the spring is completely flat, then it will have moved this way by about 2.5 inches, which is about what they're talking about in the specifications for the clearance that you want between the axle and the frame. So that's the reason that's there. If you give more clearance, then you're going to be hyperextending the spring, which is bad. And online you see lots of guys replacing their broken trailer springs, and if you look at their suspension design, you'll notice that almost always they have an insane amount of clearance between the axle and the frame. Somebody probably jacked that up because they wanted more clearance for a smoother ride, not realizing that meant that they were going to be snapping their springs off. So basically this puts us, the consumers, between a hard spot and a rock. On the one hand, you want a lot of clearance so that the axle isn't crashing onto the frame, but on the other hand, you want little clearance so that you're not hyperextending the spring. So what are you to do? Well, right here it says use of dump stops is recommended above 2.5 inch clearance. So that kind of tells you what you might do, and that is Stick with the 2 to 2.5 inch clearance, but that would be above some sort of rubber bumper or maybe some UHMW. That way, when the axle crashes into the frame, it will be cushioned a little bit, and maybe you won't be cracking your axle or your frame because they're always smashing together. So that's kind of what I've decided to do here. So I'm going to raise things up just a little bit more and give a little bit more clearance, and then fill that clearance with some sort of forgiving material that won't just fall apart. And this word dump stop, that is intended. That's not a misspelling. They didn't mean bump stop. The word dump, as used in this context, it has something to do with the frame, the spring going past flat. I forget. I looked online for a precise definition, but I couldn't find it, and I gave up. It was always being referred to as a bump stop. Okay, yeah, bump stops, but dump is a spring-specific term. If you can find it, great. And in case you're actually wondering what I'm doing here, this is the trailer I'm building, and to go along with that trailer, I have one of these and one of these, and some of this stuff that's on the wall, and some long pieces of shiny stuff that were unloaded from a flatbed with these gantry cranes, which were they were the first thing that I built after I built this shop, because you kind of have to be able to unload a flatbed.
This message brought to you by Sambo and Honky, and now by Cracker and Boy.